Background of the study. In this study, we must to observe and record the rolling of a dice 30 times to determine the result. And then we have to enter the information into a table. Afterwards, we have to determine the probability of rolling an odd number and an even number. The theoretical probability of rolling an odd number and an even number is also calculated. The objectives of this study are: first, to record the outcomes of rolling a die 30 times. Second, to calculate experimental probability of rolling an even number and an odd number. Third, to calculate theoretical probability of rolling an even number and an odd number. Fourth, to find the difference between experimental probability of rolling an even number and the theoretical probability of rolling an even number. Fifth, to find the difference between experimental probability of rolling an odd number and the theoretical probability of rolling an odd number. Significance of the study. This study aims to demonstrate the application of the probability formula. It does assist in resolving probability issues that could happen in daily life. It could facilitate students' lives. Methodology. Our group was assigned to experiment 2, which involves throwing a dice for STA150 subject. First and foremost, we need a 6-sided dice with the numbers 1 to 6. The dice must be rolled and the result must be entered into the outcomes table. In order to finish the outcome table, we will conduct this experiment 30 times.
Next is data analysis. For experiment 2, question 1 is write the exact sequence of odd and even numbers accurate in table 1 under outcomes. The first outcome is 3 and the second outcome is 8, the third outcome is 4, the fourth is 6, the fifth one is 5, and the last one is 4.
B. Find the experimental probability of rolling an even number. So the formula is probability of even equals to number of even number rolled divided by number of even experiment trials. So we're adding all the even numbers that we get from the frequency. So 8 plus 6 plus with 4 divided by number of even experiment trial is 30. So the answer is 18 divided by 30. C. Find the theoretical probability of rolling an even number. The formula is number of favorable outcomes divided by number of possible outcomes. So the answer is 3 divided by 6. We simplify it, so we will get 1 over 2. D. Find the experimental probability of rolling an odd numbers. The formula is probability of odd number is equal to number of odd number rolled divided by number of even experiment trials. Hence, 3 plus 4 plus 5 divided by 30. So the answer is 12 over 30. E. Find the theoretical probability of rolling an odd number. The formula is probability of odd is equal to number of favorable outcomes divided by number of possible outcomes. So will be 3 divided by 6. We simplify it and get 1 over 2.
For the next question is, what is the difference between experimental probability of rolling an even number and the theoretical probability of rolling an even number? Write answer as a percent rounded to the nearest whole percentage. And the answer is 18 per 30 will minus with half and times with 100%, and then simplify it, we'll get 1 per 10 times with 100, and the answer is 10%. And the last one is, what is the difference between experimental probability of rolling an odd number and theoretical probability of rolling an odd number? Write answer as a percent rounded to the nearest whole percentage. For this, the answer is 12 over 30 will minus with half and times with 100%, and then simplify it, we'll get negative 1 over 10 times with 100%, and then the answer will be negative 10%.
Conclusion. Overall, we discover that there is always a difference in the probability of rolling an odd number or an even number. We were able to distinguish between experimental and theoretical probability in our study as well. This has also proved that the use of the probability is highly significant in the topic of statistics.